That's our new theme music.
Okay, nice. So, welcome to the Elixir Roundtable with Dockyard, where the tables are definitely round. I'm Nathan Long. I'm a senior software engineer at Dockyard.
I'm Mike Benz, also senior software engineer at Dockyard.
I'm Brian Cardarella, founder of Dockyard.
I'm Chris McCord. I write Elixir sometimes. Dockyard also created Phoenix.
Created what now? What's that thing you made? I think I've heard of it. So we got some stuff we're going to talk about today. The first thing I wanted to talk about is something that I did on a project here recently. It's about how we're using API tokens and specifically dealing with authentication failures. So I actually wrote a post on the Dockyard blog a while back called Tips for Tokens. It talks about kind of the overall sort of token strategy and mentions some of this a little bit, but like just kind of like big picture, the way we're doing API tokens, we're using the Phoenix token module to sign a value that we hand out to the user. And what we're signing is a map, and the map contains the user's ID and their like raw token value that we store on their user row. And I really like that approach because when they send us the signed token back and we token verify that and get out the map, we know what their user ID is, even if the raw token no longer matches an existing user. Like if that value has been changed, we know who they were trying to authenticate as. So I think that's super cool. The only thing that it bothers me with is I like get confused about what do I call the token, the signed thing or the raw thing that comes out of it. So naming is hard, but I like that overall. But I had a request to log authentication failures. And so that could be if somebody doesn't provide a token header at all, or if they provide something that's totally bogus, or if they, if we're able to verify it, but then it doesn't match the user's current token value because we've revoked that, which might indicate they've actually stolen that token and they're trying to impersonate somebody. So in all those cases, we want to log that. And the thing that this potentially is premature optimization, but the thing that occurred to me is somebody could hammer us with invalid requests, and that could mean we're writing those, because this is still meant to be logged to the database. We could be writing a whole bunch of records to the database like as fast as they can hammer us with requests. So I didn't want that to become a potential denial of service kind of thing. So what I came up with is a debouncer gen server. And the idea is whenever we get an authentication failure, it calls that gen server and says, here's the information that was presented. That could come from a couple of different plugs. One of them like verifies the token and one of them looks up the user and whatever. So here's what we know about this user so far, basically, in a map. And then what it's going to do is it's going to gather up those maps into like a higher level map where each piece of data is a key and the values are counts. So how many times have we seen a request just like this one? And then periodically write those, which is just every couple seconds, but it could be configured to be whatever. So does this all make sense so far?
Yep.
So what it does when it writes, it does a bulk insert. So if we've got 10 or 100 or whatever, however many different unique values, maybe like we got this one 5 times and this one 100 times or whatever, it's going to bulk insert those as rows all at once. So the basic state of it, it's got a batch start time that it tracks, which can be nil if we're not currently doing a batch, if we're just sitting around getting no requests. And then if we start a batch, when we get one of those logs, we start a new batch, and I use a system monotonic time to set the beginning of the batch time. And then there's a duration of the batch in milliseconds that's configured in the application config. So under constant load, we're going to write whenever the max duration is reached. So we'll just say like, I got another request. Every time I get that, I'm like updating the state, and I'm like, now is it time to write? Now is it time to write? Okay, yeah, I'm going to write. So even if we're getting hammered all the time, we're going to write occasionally. If there's a lull in the writes, or like if there's a lull in the requests we're getting in, we're still going to write because we're using a gen server timeout, which is like when you handle cast or handle call, you can do like, in this case, I'm doing handle cast because the senders are doing fire and forget. They don't care about when we write this stuff. So I do like no reply, updated state, timeout. And what that does with gen server is if you set a timeout value, let's say 500 milliseconds. If there's already a message waiting in the mailbox, that does nothing. It's just going to go right to the next message. And if another message arrives 400 milliseconds later, it also does nothing. It's going to handle that and just totally forget about your timeout. But if 500 milliseconds pass, then it's going to send itself a timeout message. And then you'll have your handle info, I think, for timeout that you'll use to deal with, okay, now that lull actually happened. So we write in that case as well. So if we're under constant load, we write. If we get a lull, we write. And then we also use def terminate so that if we get shut down while we still have some state to write, we'll write that, like flush that stuff at the end. The only like other piece there is that the duration of the batch, there's a trade-off there. Like the longer you make that, the less we're going to be hitting the database. The more this is kind of like doing its job to reduce load on the database. But also, the longer you make that, the more potential there is for we crash or something and lose all that state that we have, or that we get bloated because whenever we write, we clear out our current, like throw away all the memory that we have, all the requests that we've logged so far. But so if we were to get a whole bunch of requests that are all identical, that's just going to be a large count on that same request, and it's going to be like no memory used basically. But if we were to get a whole bunch of unique requests, that would be bloating the memory of this gen server, and that could be a problem eventually. So the more frequently we can write and clear out the state, the less likely we are to have that thing bloat memory and fall over. So that's basically how it works. Have you guys used anything like this? Do you have thoughts about it?
Yeah, so I think the key word you mentioned was like the trade-off of like depending on how you configure this thing, you get there's certain trade-offs. So I think I mentioned to you on the Dockyard chat, like, it sounds like there's like cap theorem issues around this. We're only talking about one single node right now, but I think that's the key word is the trade-off there. It's like you can either be more available or you can lose rights, and like you have to know which one of those you want. So it's like, in the initial mode where like you always do all rights, it's like, well, we never lose any data, but then your system's not available from someone on the internet. So I think I think your instincts were right. Like, you mentioned premature optimization, but I think anytime you're like, could someone take this app down from their laptop? And if the answer is yes, you're like, well, we need to handle it. So I think your instincts, to pay this up front versus a report that, oh, the app's down because someone with curl was able to, take it down, was the right intuition. But I think, yeah, around like cap theorem, which is like a rabbit hole we can get into, I think applies here. And maybe we could talk about like how this would work multi-node, but I think like ultimately it's like I'm not a cap theorem expert, but it's like either you can be, it's like cap theorem is consistency, availability, or partition tolerance. And you can't have all three, like because of the laws of physics and the way reality works. So in your case, like, we are favoring having the system be available versus it being consistent. And that means like if we're not consistent, we're losing data. And I think for an attacker scenario, we can lose data, and that's where you have to actually answer the questions up front. So I think the more people use Elixir and start thinking about distributed problems, like you necessarily have to know what kind of guarantees you want out of your system. And there's no right or wrong answer, but you have to know to ask, like, you have to know what question to ask. Like, what do I actually want here? And in your case, you're like, well, we can lose some rights. And you're like, well, if someone's attacking the site, whether they hit us 1,000 times in that window or 10 times, like, it's not critical to know that specific count, right? It's just, we would like to know over this period of time, are we getting attacked by this user? So I think the trade-offs there, you have to know upfront, and then you just opt into one. And it may feel wrong if you're like, well, I can lose rights sometimes, but that's sometimes the answer that you have to have because of the reality of the world.
Yeah, and there are types of rights in our system that we definitely wouldn't want to lose. I mean, this is a system where people essentially request work to be done. We never want to drop one of those. But this data, like you said, is we lose some of them. We're already under a kind of an unusual scenario of being overwhelmed with these requests. You know, if we're being overwhelmed with authentication failure, something weird is happening, and it's really just a matter of like, which is worse, to record all of the things they're doing to us and die because of it, or maybe not
Right.
record all of them and not die because of it.
Yeah, I mean, there's a whole topic like it's like called load shedding, where you could actually try to perform all work, and then you detect you're under load, and you actually start shedding that load. So like you're more consistent when you can be, but then you still ultimately enter that same window of losing stuff. But I think being able to, like you said, there are certain cases where you absolutely can't lose rights. Like thinking about that up front drives the architecture. Like Mike and I worked on a architecture for a client kind of around this idea. I mean, like up front, we were like, you know, what it is, like, what are we trying to build, and what are the scale requirements, and that kind of drove how we built everything. And part of this thing we did had this requirement, like, well, this thing needs to be entirely consistent, because we were like leasing out claims on an item, and if we wanted to become more available, like everyone rushes in to get a claim, like we could scale that, but then multiple people could end up with the same claim, right? So it can't, we couldn't focus on availability as its own self, because it had to be consistent. So it informs how you scale the system, because if you're like, well, it has to be consistent, where like you're then scaling like horizontally on your deploys, right? Because you're like, well, we have to handle this in one place because it has to be consistent, whether that one place is the database or an Elixir process somewhere talking to the database. That informs kind of how you allot resources on the cluster. And if it has to be in one place, then you know that, okay, I'm provisioning instances to handle these things. And then you kind of plan from there, versus kind of just like not thinking about it up front, putting it in the database till it becomes slow, and then you have to work backwards. So I think thinking about these kind of guarantees really helps drive, I think, what you're architecting in Elixir.
Yeah. Y'all talked about some of the stuff, the specific project you're referring to. Y'all talked about that internally. I think, Mike, you're going to do a talk related to that. I don't know if you're going to get into the technical details or not. Can we tease that? You're hoping to do that talk.
I'm hoping to. It was one of the submissions for Elixir Conf. So yeah, we'll we might see. I don't know when those will be announced, but yeah, that'll be one of the things we get into, is that sort of stuff if we do that talk.
Yeah, that was a really fun internal discussion.
Yeah, I'm excited. Yeah, hopefully we can share some of that publicly. But I'm interested on the multi-node scenario. I'm assuming multi-node is not, you're deploying this to one node currently. Is that an accurate statement?
Yes. Currently, we're deploying this particular piece of the system, just one node. So yeah, thinking about if we had multiple nodes, like if they were being load balanced or something, then we would hit the database twice as much, essentially. Like,
okay, yeah. So it still works though. Like you're still debalancing, and then you could even upsert to do. You could even collapse those counts. Like instead of clobbering last write wins on the debalance, you could actually, you were load balancing the same user to different, as you're incrementing those counts, you could actually upsert in Postgres to even save those values. So
yeah,
the model still works there. Whereas like, yeah, for other times you may have to, so you can still be consistent as well, at least when you actually perform the write. And the other times, like I gave a talk on rate limiting, where if you have nodes that are doing things and not writing to a consistent store, at some point someone's going to overwrite one another, and sometimes that's okay and sometimes it's not. Like in your case, it may be okay if that happened because it's not mission critical data, but if it's financial data, then you got to come up with a solution for it.
Yeah, the way I've got it set up right now, like if two different nodes each got 10 writes in the same period, you would just have two different rows that each say 10. Like each say count 10, and then you'd have to kind of like if you really want to know the right answer, you'd have to say, oh, well, these two were during the same period, add them up.
Right. But for your purposes, like this is more like a forensic analysis, not like how many sales did you make.
Yeah.
But I think
hopefully this code never becomes important.
well, I mean, it serves. Yeah, I mean, it's serving the role, like you said. It's logging bad things, but also not taking down production, because that's the other thing. Like, you don't want to instrument your system to make sure, like, when stuff goes bad, you know about it, and by doing that, it makes stuff go bad. Like, defeats the purpose. So I think it's the right approach. I do think there are probably ways to optimize your optimization. If you want to talk about that, maybe I haven't been part of this project, but I think one thing that came to mind with you're talking to a Gen server, and I think my understanding of this particular client is, I just want to be clear, like, I think what you currently have written is probably all that's needed. So this is kind of getting into the weeds, but we are putting a single Gen server, it sounds like, in front of web requests, which I think what I understand about this current client, this is totally fine. But if you're at like very high scale, that could become a bottleneck. So there are a few things that you could do here. One, you could add more processes. Then you kind of get into the distributed case, but happening on the same node, which I think would just work kind of how we said. But the other easier option, I think, is you could have this this debounce server write to an ets table, and the web request caller actually will just check ets to say, have I actually, do I have a pending item with account already? Like, have I talked to this already? And am I currently being debounced? So you could actually do this kind of ets offloading where you don't talk to the server if you know that it's currently debouncing you. Then you still have to worry about, like, well, do I need to tell about the count to bump the count? And you could allow writers to actually write to ets. You get into potential data consistency issues there. But again, you give yourself availability. So it's just some thoughts there around, like, putting a process in front of all requests could be bad. You could offload that by just not calling the process, and usually ets is a way to do that. But then if you're offloading state into ets, then you have state in two different places. So there's, again, trade-offs is the key word.
Yeah, another maybe option would be to use, was it p-hash, where you could, like, take the value and figure out which one of the debouncers to call.
Yeah, but so that's one of the, so like you either, like, if you have a process scaling problem, you either add more processes or you talk to the process less, and, like, those are your only options. So yeah, one of the common approaches we like to do is, if you want to start more processes, and you can't talk to them randomly, like, you could randomly say just pick one, but then in this case they need to know who they're debouncing. So you could, Erlang has a p-hash function where you could just say take the user ID and hash it, and that will tell you which of the N shards that you've configured you're going to go to. And that's happening, like, we do that in Phoenix PubSub. I think Elixir's registry is doing partitioning similarly internally. So that's a strategy. That's what the strategy Mike and I use in this application that we may or may not be able to talk about at ElixirConf, where we are sharding the cluster horizontally as needed, and we pick who to talk to based on, an ID, and it's like, well, talk to this server, and that allows you to kind of plan for scale, but not dynamically scale. So, but a deploy later, if you're like, well, I need more of these, then you just bump the value.
Cool. Yeah, anytime you have, like, a hashing kind of situation where you're hashing to decide which of these three things I'm going to send something to, and then you add more options, you have to go back and change how you're hashing, right? So now you're hashing among 5 options or whatever, right?
You have to,
It depends.
Tear down the nodes. Well,
I mean,
depending on what's actually where
the data the data that you're hashing on could just be like one primary key ID, and then if the data structure changes, that should still reasonably balance on the shards depending on the type of ID you're using. But if you change the shard size, you have to bring everything down. That's the only thing. That's the hard stop of, like, if they're now 6 instead of 5, if you don't tell other servers about it, then they're going to send it to the wrong place, and then you have a consistency issue because the server will probably accept it, and be like, yep, I am shard 5, even though, product 5 should be now going to shard 6 instead. So that's the only caveat. But what I found is like Elixir scales well enough that instead of like worrying about auto scaling, you're just like, well, what's our expected traffic? We need 5 servers. And if you're like, well, 5 is too slow, you're like, okay, add 2 more. And you increase the shard size and you deploy, and then you're good for a year, has been my experience.
Nice.
It's not entirely comparable to what you're doing, but there was a Ruby library that I wrote years ago because we were using different error logging solutions at the time. I think one of them was, forget the name of it, but Thoughtbot wrote it. And the pricing, the monthly pricing on the error logging as a service was incredibly high. Like it seemed like all these like error logging services, they kind of like use their business model price points justification that, if your critical mission, like mission critical system goes down, you're losing more money than you otherwise would have saved if you use the error logger and you quickly fix it and get back and back up and running. So looking at these things like, these are too expensive. So I wrote this, was really a Rails engine, but called Party Foul. And what it did was it would overload the, I forget what the standard error or whatever the like ultimate, like somewhere in Ruby's like crazy graph of object inheritance. At one point, there's like an error object that ultimately derives into all types of errors. And you can overload that and basically call out the party foul. And what it would do was it would log to GitHub and on errors. And so we would get into a thing
a GitHub issue, right? Like an issue.
A GitHub issue, yes,
yeah.
An issue. And so early iterations of this, like we maxed out the API calls. This was earlier on in GitHub too, where I assume they were more permissive before they would shut you down than now. Like there was one that I remember we opened up like 1,000 issues in 5 minutes or something like that. And so what we started to do was, trying to determine how errors are related to one another and keying off of that. And so, well, again, Nathan, while this isn't like super related to what you're talking about, it did remind me that what we ended up doing was we look at certain aspects of the request, like this, I think the action, controller, a few other things. We take all those things, those unique pieces, and we would hash that, and we come up with a unique symbol, and we would search the existing issues to see if this hash existed or not. And if it didn't, then we would create a new issue. We would inject the hash as a piece of metadata in there, and then if a new error occurred that had the matching hash, we would just add a new comment with some relevant like query params in there. In theory, that made a lot of sense, but what we quickly realized is that sometimes when these errors are happening, they're happening faster than the GitHub API can respond to tell us that this is a unique issue or not. And so, it'd been really nice to have some of those debouncing options back then in the Ruby times, or maybe they existed, they just weren't that as well thought out on the Elixir side of things.
I just realized a second ago that because I was muted, the audio version of this podcast will not record that I was laughing when you started talking about it. Opening GitHub issues for every error. I was thinking that has got to be a violation of the terms and conditions.
Yeah. I wonder, hold on, let me look it up because it's still out there. I don't know if people are still downloading it. Let's see.
I think I was aware of it prior to joining Dockyard. I think it came across my radar in the Ruby community. I mean, it's pretty convenient unless you have these
brilliant idea.
Unless you have like a million issues in, but it is convenient if you're like, you can actually close out that issue in a commit. Like it's a feature. Like
yeah,
one, it's free, but also pretty convenient unless you've got like 300,000 comments on an issue or something. Gotta be careful.
It's funny you mentioned that because we're actually dealing with a similar issue with with the current client on logging and turning those into issues with App Signal, because by default their Elixir plugin it's based on the unique name, but the name is the name of the Elixir error. So like all of the function clause errors are thrown together, which is completely useless because you can have 10 different issues that are totally different things, and undefined function error, or ecto query cast error. So we just basically we had like 4 errors, and there was just each error had like a million different instances, and they're all different things going wrong. So you couldn't like track it well. So I pushed, forked it, and tried some stuff, and basically took the entire string of the error, the message, and made that the name. Well, now the problem is the same issue happens, 100 times with different PIDs or different timestamps, and now they're all there. So trying to figure out some sort of like you said, Brian, trying to figure out what is a different issue and what is the same issue is something that I think they're working on from their end. So
I mean, there's 2 ways to do it. Either you go through that pain of having to normalize and unique them so that you can offer a higher signal to noise ratio for people to wade through, or you just log everything and say, okay, there's a screw up somewhere. Now we got to dig through it to figure out what it is. Because I think that if you start, my recollection was like, as soon as you start going down trying to group together errors and like really like force some of them to say these fall into like a similar error bucket, you're gonna have things fall through the cracks. But I mean, it's a trade. I mean, this goes back to what Chris was saying. It's a trade-off on all things. Like, do you care about catching the 80% of things and getting it done fast, or do you care about like that last 20% sometimes? I mean, the show-stopping ones, I don't think are really going to be that effective to have the error logging in place, because the show-stopping one is, I mean, you're going to know pretty quickly, where that's occurring. If it's bringing down the server, if it's just like users not using the application the way that you intended, and you're just like logging like all these all these routes are just blowing up for some reason, like that's where I think the error logging services are more useful, especially when it comes to outside of regular feature development cycles, where you're just okay, we got to catch up on the backlog of where things are rough.
Yeah, I wonder, it's in having waded through a lot of these errors, I wonder if something like the last 5 or so lines of the stack trace would be unique enough to say this is its own issue, right? Because if you're hitting issues on a single line are generally the same issue or variations of the same issue.
It might. We didn't end up using the stack trace for party file. We would embed the stack trace. We'd capture it and then put it in there. But yeah, it could.
Yeah, I mean, it's not an incentive with these services though they want you to be granular, I'm assuming, because you're paying on requests or storage, so it's probably part of the problem. Okay. Like the defaults are probably pretty noisy. I mean, one, because I guess it's better to have everything than by them for default have you lose stuff, or coalesce things. But I think this is a problem in general. Actually, so if Ian is listening, I had someone recently, they exhausted like their million requests. I don't know if it was Datadog, it was one of these services. The Phoenix.js has an on error hook on the socket that you can say, like, if the socket has an error, like connecting, or it drops, it gets invoked. And he put like a Datadog client side report of JavaScript errors in there. And it turns out, like, as your live view tokens expire in the background, those tabs are still going to try to connect, because you get booted, you reconnect, it says the token is valid, so the connection isn't upgraded. So then it tries again, and like it uses exponential backoff. But he like deployed this and then like exhausted 1 million requests because of X amount of users out there with tabs open very quickly. So like seemingly he was like, I want more insight into my connections, and it was like instant like 1 million requests sent off to the API, and goodbye whatever plan he was on. So I think this rate limiting problem is interesting, but I'm surprised though that like you think if a service got, especially from a client side, like, you know, anyone could just write a for loop. You think if they got like the same data from the same client or IP that they would at least try to filter that, but apparently whatever service this was, you could just from any client exhaust someone's tier of pricing.
Yeah, that's interesting because yeah, like you said, if it's going from someone's browser, then anyone anywhere could trigger those. So there's got to be some sort of protection in there, or something I'm missing.
Nope. But I guess not for this. So yeah, it was surprising. So I think yeah, it was just you add like an on error, and you're like, oh, there's an error, report it, and then it was like, well, this could be called like, you know, we do like 10 milliseconds,
10,000,
50 milliseconds, 80 milliseconds. So like every client, you know, is like within 1 second has tried 10 times to reconnect, and then it gets slower and slower. But you can see that like any tab at scale is like bad news.
Yeah. There's the what you're talking about there. There's the issue. So at least with the systems that were the app signal we're working with, I think Sentry is similar. Is you send everything off from each incident happens and gets sent off regardless, and they're just kind of grouped on their end based on, I think so. App signal groups it based on whatever name you send. So as far as and I believe they're all costed out, or their price tiers are based on number of incidents sent, not necessarily the grouping. So regardless of whether unless you were to catch a bunch of them locally and only send one, you'd still be paying the same regardless of whether the grouping is accurate or not, whether, you know. But yeah, it's it'd be nice to I think I had better experience with this in Sentry. It was pretty accurate as far as figuring out what error is different.
Yeah, this is a problem too. I won't name the service, but I've been made aware that Elixir applications, I guess, completely destroy like the agent that runs on a server for one of these reporting services. Like it reports errors faster than the agent can report them upstream, and like actually takes it out and crashes the box, and which kind of goes to Nathan's debouncing thing. So I don't know. I haven't looked at the source. I think it's written in Rust. Since it's an embedded agent that listens for errors and then reports them.
Yeah, there's a NIF.
Okay, yeah, and I don't, like I said, I won't name the service, but it actually, like, I'm assuming they're not debouncing. And again, this goes into like, well, if the agent debounces, it doesn't send an HTTP request to collapse, you know, a bulk request, it could potentially miss some things, but instead it just completely falls over and takes the server out. So Elixir's too fast for, I think, one of these native things running just because it can't keep up with what's being sent to it. But again, like, this is the problem. So it's like, do you want your whole server to go out or do you want to remain available? And it's like, well, then you have to make a choice. And apparently, I mean, they made the choice in the agent, but it's just funny that it's like a native implementation and still can't keep up.
But I thought, according to that one guy's website, that Elixir was much slower than Rust and all these other languages and frameworks. What's going on?
You're trolling, but that comes up on Hacker News a lot too, about Elixir and Erlang being slow. And like, yeah, it's so loaded, but you're like, yeah, I don't know. It's like if you're sending something to a single threaded NIF that makes a HTTP request, like, you know, and does blocking work, then it's going to fall over immediately. So it's like, yeah, there's a ton of nuance to that slowness, but it definitely grinds my gears. And now that we have NX though, it's like we are competitive on most fronts.
I would even say it's exceeding. I mean, the interesting thing with the NX project is I know that they're catching up on ground that took time to be researched and developed. And so I may be out of place to say that there isn't a lot of original work going on. It's like, you know, catching up to the state of the art of what Python, other languages have. But that being said, the pace in which they're catching up is like ridiculously impressive. I mean, this is, keep in mind, these spaces are areas that you have multi-billion-dollar companies funding the research and development on, and the NX project is, I mean, it's, you know, one guy working part-time that works for the Army, and then working on a part, like in between his Army business, he's working on it. And then Jose,
it was like what, 6 months old? Like it's not very old. Like they it's not like they've
no,
been
they started,
working
yeah,
on
less than a year
that
ago.
long.
Jose and Sean got connected, I want to say December of 2020. It was November or December, and I don't think they even started like writing anything until maybe the new year. And then with Livebook too. My understanding is that Livebook is functionally going to have more going on for it than Jupyter Notebooks will, because they're going to have, I don't know if it's being worked on yet, but Jose was making mention of multi-language support. I don't know if that may have been something they just dropped as like nice to have, but like running all these different languages in the live books, if that is actually going to be in scope, yeah, I think would be, you know, really, really impressive.
Well, just collaboration. I mean, I'm not in the Jupyter
Right.
space. It's my understanding that they don't have collaboration. I think there's a startup that was on Hacker News that had like X millions of dollars in funding. That's essentially just a collaborative notebook platform, and like they did it in Livebook in like 6 months. Like I mean, it's just with, again,
Well, like
like
6 months of like working on it when they can, right? It's not like
Right.
actual dedicated
So
6
I
months
think,
time too.
yeah, the pace with Livebook is incredible. And then so Mike used it earlier in the day to show off to the whole company something he's been working on. And I messaged Jose because like it's the first time I've seen someone in earnest just use Livebook, like versus like, okay, look at this new feature on Livebook and talking about the details of how it works. Like Mike would just used it to like a bunch of Elixir and non-Elixir people, and it was really really neat just to see it used as like a product. And everyone was just like, oh, what website, like did you make a website for like this whole presentation? And it's like, no, this is like, I don't know, it's just really neat seeing it used in the real world in earnest, outside of like worrying about the details of how it works. So it's just like,
Yeah.
Mike had like documented code explaining what was going on, then he executed that, we got to see it in real time. So it was really interesting from a non-developer viewer point of view. Like everyone at large kind of got to see what was going on and understand it visually, which versus like going to the terminal and tweaking stuff. So I thought that was really neat.
One thing I haven't seen, and Mike, we spoke about this briefly, was training in Elixir using Livebook.
Yeah.
I mean, it seems like it's just the most obvious use case for it.
Yeah, definitely. I mean, that's you know, like Chris said, you know, I'm working on this side project, and I was like, all right, well, you know, if I'm going to release this, I need to go through and do a README and like explain what's going on and how to do it and stuff. And I was like, well, instead of, you know, a README, which will eventually have a README, but I just started with a live book. And you know, in the live book itself, you know, there's some third party or there's some things that need to be installed. And so in the live book, the first line in the live book is, you know, calling system.command brew install whatever. And so like you can take those steps, even the setup steps in that, and then get into actually, all right, this is the code, this is what you would add this to your mix file. We're going to use mix.install in this live book, and it does that, and you get right into it, and you're off and running code.
Can you get push GigElixir on Livebook? Like, is it built so you can deploy quickly to GigElixir, or do you have to go through like still jump through some hoops for if you want to host it?
You could like shell out. I mean, I don't think you could make like a button yet. I know that they're working on like a component type, like you could actually have a button that like does something. But you could, I mean, worst case, you could actually just like system command git push GigElixir, right?
Yeah, right. Well,
No, I mean from within the Livebook. I mean, are the dependencies of Livebook such that it like would not work out of the box on GigElixir right now?
Well, there's a security issue, right? If I'm understanding it correctly, like if you have access to Livebook and you can run it, you can do anything on that system. And so the
Right.
idea of even
Okay.
having a hosted live book, I don't think at this point makes sense.
Yeah, I mean, you could lock it down, like the URLs are signed, and then you could put authentication in front of it. So a publicly
Yeah.
hosted one, yeah, you're basically the
Right.
floodgates are open to the root the system, but
Right.
yeah, you could put, you know, authentication in front of it, and then anyone that has access to that box with authentication can do anything they want into that machine. But
RMRF.
yeah, so
/
it's like with those caveats of like,
Yeah.
you get access to it, you have access to the world, then you could deploy it.
So Mike, for your thing, you're thinking people will download, like clone your live book plus project repo and run it on their own machine, and that's why you've got the install and everything.
Right. Yeah. And I think if I'm thinking of it correctly, I think as long as they have Livebook on their system, like the global install, they would just need, all they would actually need is the Livebook is it dot readme? There's a whatever
Like
the
live MD, I think.
LiveMD, yeah.
And you can
So
you can give it that URL, like your
right.
empty live book, you give it the URL of Mike's live MD file, and then it's just like, boom,
Right.
there it is.
Exactly. Yeah. And so then like I said, you know, what the first step is, well, the first step is installing this other stuff. But then, you know, if you wanted to demonstrate whatever your package is, you mix.install right out of Hex. And so they don't even need your repo. They just need your live book. And then within that project, the live book session, you know, it'll get pulled down and installed. So yeah, it's cool. It was really nice. It only took a couple hours to put together the live book. And you know, what was interesting was, the first thing obviously was, I was like, oh, we want to show them how to install this on Brew. And my first stab at spinning up a live book was just run the Docker container. The problem is the Docker container is its own internal thing, which doesn't have Brew. And so my local machine that did have it, I was assuming it would tie into that, and it didn't. So I did end up going with the Hex archive install option. But yeah, that then allows it to be run from anywhere. So.
And then before we ever run out of time, I did have, if we wanted to loop back to Nathan's original problem, and I don't even know if it's cap theorem, but I think I had another thought earlier around this idea of like thinking up front about, like, you've got something happening a lot, or a series of things happening, and then you take a step back and you're like, well, what's important to actually record what happened or do the side effect of the things that have happened. And I think you can generalize this thought process to designing any Elixir application, because what we're seeing in a new project I started is a problem that we've seen in other projects or many projects, but I don't know if we've talked previously on other media outlets, but like we had one client project that came in the Elixir app. We inherited it. It took 6 days to run this indexing process, and we cut it down to 6 hours using the same Postgres database, same Postgres schema. Just because what was happening was they had all these things happening as the program indexed a bunch of data. And I think people coming from non-preemptive scheduled languages think that anytime they need to do something, a bit of work asynchronously, they need to go do that somewhere, and just that one piece of work, because it's expensive to hold a thread open. In Ruby, you know, you only have a certain amount of workers. Even if you have a concurrent threaded language, you only have a certain amount of threads. So what we see happen is people come to Elixir and they're like, well, I have to perform this bit of work. I need to go run that as a task in a process somewhere. So they start a ton of processes to do this one little bit of work. And that, while processes are cheap, that can scale very poorly, especially if all those are then talking to the database or doing a bunch of work that needs to be coordinated among the processes. And that's how you go from an Elixir app that takes 6 days to 6 hours, where we took a step back and we said, like, what's important to actually happen? You have all these things that need to happen, but where do they make sense to happen together? So kind of like Nathan's persisting at the end, like you have this window, and then what's important is the side effect of the things that happen over this window is what we want to insert to the database, not each individual one. So from like a job queue standpoint, I think it's important to take a step back and say, okay, like when we were indexing this thing in the database, we had transactions, and then those transactions had a bunch of like receipts on them, and it was creating a job for the transaction. It was creating a job to go through every receipt. Those receipts had another thing in the database that had to be created. So instead of, let's say, 100 individual Elixir processes that all insert data in the database over the network over and over and over, we said like, well, what's really important is we have a transaction, right? A bunch of things need to happen. We got to hit external APIs to index and populate the data. And then at the end, we represent this parent transaction with all of its receipts and data, and we send that off to Postgres. And that one bit of work was a large bit of work, but thinking about how it actually fits, whether it's like error reporting, like we were talking about, like how do you actually group this data together to what really matters, and then you push that off to the expensive thing, I think applies to everything in Elixir if you're trying to operate at scale, whether it's error reporting, whether it's just ingesting user traffic. If you're sending a comment into the user, or if you're sending a piece of data into the system and that comment needs to be indexed by the search engine, needs to be sent into Postgres, needs to send the email to someone, like you need to think about like what needs to happen completely separately, or what can we actually collapse as like, okay, this thing happens, do all the work. You can be expensive as you want, you can block as long as you want because a process is preemptively scheduled. So it's kind of a brain dump there where I think this one debouncing case is actually a broader like paradigm in the language that we could probably generalize.
Yeah, and what you said there also kind of reminded me of something that it's about like looking at the problem at the right level, because I worked on a system at one point that was dealing with some scheduling stuff. And this is actually in Ruby, but as sort of the single responsibility principle, they had broken the system down into such small objects, like everything had its own tiny little thing to do. But the problem was every one of those little objects was querying the database. And so, big picture, what we needed was to grab all the data we want that's part of this report or whatever, and then do stuff with it. And not, so like the responsibility is grab all the data. So like really running one query versus running a ton of queries was a huge change to the system. It went from like unusable to like you don't notice how fast, like it just happens, like you can't notice it executing. And just thinking about the big picture and where to break things down is such an important like architecture thing.
Yeah, absolutely. That was a much simpler way than what I said. But yeah, like you said, do things up front that make sense, and then do the extensive work. But I think that's why you hear in the community like job queues versus you don't need a job queue, is like job queues matter, but only when like you actually want to do this one bit of work and have it be durable and have it be retried. But it may make sense to not do that and just start a process that does all the work, or make one job that actually does a bunch of stuff. So I think it's like, that's why there's this back and forth in the community, where it's like, I think it is important to step back and not just like, oh, put everything in a job, but people don't really hear the nuance of like, you actually have to think like, what are you trying to do?
Cool. Anything else we want to talk about?
Nobody has made note of my high definition camera. I'm very upset. I have no idea if it actually looks high definition on everyone else's screen. But
we got to see you eat cereal in high def.
Yeah,
I bought this ring light thing, and I got my phone hooked up to it using a program called Camo something, and it basically uses my phone as the camera, and it works pretty good. And then I saw maybe yesterday or the day before, the new MacBook Pros coming out in the fall, I guess, are finally supposed to bump up the FaceTime camera to 1080p, I believe. They're currently like 720p, and they've been that way for about 10 years now. Anyway, I wanted to solicit some compliments on my high definition camera setup.
It definitely looks higher definition, although the color has been a little weird. I don't know if others are seeing that.
I'm sunburnt. No, I'm sunburnt.
No, but you've been like getting more and less sunburnt sometimes during the
I think it's
call.
probably the ring light. I think if I go forward and back,
Oh yeah,
it
there
may
you
just
go.
be adjusting it. And it's probably also just like how the iPhone tries to optimize the picture, because it's just using whatever lens setup iPhone has. So I like on this app. I think actually I don't know if I can change it while it's
like
happening.
Nathan, you're like, yeah, it looks clear, but just something like in this area is just very.
It looks clear. It just sucks.
No, I mean,
Okay,
what's
here I am. I'm leaving. Goodbye. Goodbye.
Just that
Goodbye.
your face
goodbye.
is so horrible.
Not
Did
so
you
much
also-
here, but right
Yeah,
here.
just like
Exactly.
somewhere in between
It looks-
here.
yeah, it
it's
looks all right.
bad.
Did you update your Google? I mean, who knows what Meet is doing as well? Like, it's probably downscaling.
Oh, so it looks bad. It doesn't look high definition.
No, I mean, it
Bitch.
looks fine. I mean, what's your?
It looks fine. Yeah, no big deal.
What are your camera settings? Like send resolution.
Oh, send resolution maximum.
Is there-
Yeah, let's go high definition. Oh, it maxes out at 720.
A sunburn
Okay,
setting.
so you may be already exceeding what it can do. I mean, it looks good. I think I would say that it looks better than our other squares.
I'm trying to bring a little bit. I'm trying to step up our game on the Elixir Roundtable.
I see. So I'm at least
quality.
in it. I'm at least at a desk versus being in bed from last time. So I'm doing my
Yeah.
part.
My contribution to our video quality is that I blur my background so you don't focus too much
I
on
know,
clutter.
Nathan. I was saying you kind of look like a shrinkadink because like it looks like you're cut out. The way that Google, like, however they're figuring out like what to cut off, is funny because sometimes if you move around a little bit, I think it probably does like some sort of sample to determine like what hasn't moved, right? And then just okay, we're gonna blur that section. So like you move your chair, there'll be like this whole like block of area that will like jagged edged block that will like come into focus for a second and then go blurry again. Like the zoom like the way that Zoom does it, it's probably like the same underlying like algorithm, but it just seems better like the way that Zoom does it than Google Meet.
It uses hardware acceleration because I know because I disabled hardware acceleration for performance reasons, and then it wouldn't let me blur. So, but yeah, there's some interesting stuff. Like I know I can like trick it into thinking that the picture on my background is part of.
Oh yeah, yeah.
So it's just AI, right?
Yeah.
Or machine learning, whatever you want to call it.
So we just need to get a green screen for me, and then
I
can
was
be
looking into
big.
that, just like a backdrop. Like there's like when you get into it, because podcasting and all like the YouTube people, there's so many people trying to get into it. There's a whole, well, it's like that whole saying like you don't want to be, one of the guys going out digging for gold. You want to be the guy selling the shovel, right? And same deal with all this industry is there is so much stuff out there in terms of like just little things. You can get like a little surround that is a like a sound absorbing material and you just like pack it around yourself and turn what is normally a large space into a small space. You can get a green screen, just drop cloth. You can get, I bought this thing, better microphone, but that wasn't that expensive. It was only like $30. I don't even know if it's that much better than my AirPod headphones. But like the whole microphone scene is you can easily go out and spend like thousands of dollars for what seems like diminishing returns on audio quality. Like at some point, I just stopped noticing what the difference is. Maybe like pros will notice, but
Yeah, it depends on what
don't
gear.
know.
Yeah, if all you're listening is AirPods. But I like that you're like, you're aware of the sell shovels, and then you're like, and then I went and I bought a bunch of shovels.
I don't know.
Yeah.
I spent less
ring-
than $100.
Okay.
I tried out the whole ring light thing for a bit, and it didn't work. It ended up on my workbench in the garage as a light for the lathe.
Yeah, like
so
I have a simple one. I can actually cycle through.
Yeah.
This, and I think I have
Yeah.
different colors. Here, I'll change the mood.
there you go.
There we go.
You can put it on Zuckerberg mode.
Yeah, like
the
how do I
white- the
look
white.
like goddamn Data
There
from
we go.
Star Trek? Yeah. I think this is actually probably the light the color I should be using. This one right here.
Yeah. At least with the sunburn, it kind of cleans that up.
Yeah. See if I can show my sunburn. This is really interesting for everybody that's watching.
The Elixir
will-
Roundtable topics.
Yeah, we'll have to do a cut and just be like, yeah,
Yeah.
that's right.
Well, I do have two blog posts that I wanted to bring up, and one of them was actually came today. And I like seeing these type of blog posts because I think that it does a good job of going on evangelizing the language. And he hits on a lot of the topics. So he was probably on a bunch of places, but I saw it on I think I saw it on Hacker News. This guy Sergio Matai, he writes a I love Elixir blog post, and the subtitle is "Elixir made me fall in love with programming again." And I mean, you speak my language here, because I kind of felt the same way. My last kind of language before Elixir was JavaScript, and we're not going to go down the JavaScript rabbit hole right now. Again, this one, we'll leave JavaScript alone. But the point being is that I was pretty burnt out on it, and Elixir did, kind of refresh me and kind of bring me back into everyday programming for the most part. But he touches on some really good points about previously, I suppose he was not using functional programming, and kind of getting into that, and then how well built Elixir is from a tooling perspective, and all these things. So it's always nice to see other people kind of validating the thoughts that I have on why I like Elixir, and seeing more posts like that out there. And I would encourage anyone that's listening or watching that has not written a post similar to that. Just, there's tons out there. We could use some more. So, write about your own personal experience with Elixir. It's always helpful. And then the other blog post was a surprise blog post, because I saw it somewhere, and this has happened twice now. And I'm not trying to make it seem like, Dockyard's this amazing, badass place, but I go and I've seen blog posts now where I go and I read it. It's not on Dockyard's blog, but then I see like, oh, this post was sponsored by Dockyard. What is going on here? So there's one called The Human Side of Elixir. And I still don't have a clear answer if Dockyard wrote this and had it posted on this guy's blog, or if he wrote it and Dockyard sponsored him to write it. But it's kind of like it's a small little tour on, I guess, companies that may be interested in using Elixir, and what what they should expect when it going out to hire, if they are going to have success finding engineers, and if not, how they can go about bringing in engineers and training them in Elixir. And I thought that was of interest. I'm not sure if any of you guys happen to see those posts or not. Sounds like no. Nobody saw them.
I haven't read those particular posts.
I saw one that we sponsored.
Yeah, I'm pretty sure we're not writing this stuff. I mean,
I have no idea.
The author that's on there is the person who wrote it. That Dockyard just gave them some support.
If only we had access to the Dockyard owner, we could be like, hey, what's the story here? Who wrote this? But
I don't know. You do have access to the Dockyard owner. I have no idea.
There was one, I think, LiveView related that I read that as I was reading it, it was sponsored by Dockyard. It was the first time I was like, oh, really? Cool.
That might have been the other one.
So I haven't seen those two, but yeah, anything that
was that by Lars? Was that the one by Lars?
I don't remember.
Okay.
But yeah, I think any content, especially around adoption or any kind of evangelizing is good, and I think just sharing your successes. Failures are okay too, just depending on the title. Like the failing big with LiveView one was an unfortunate title that evangelized LiveView, but it looked like it was a negative article. So I think any content is good. Sharing experience is good. Be careful with the titles.
Yeah, F Elixir, F everyone that ever touched Elixir, and then the blog post is just about how great Elixir is. So that'd be
Chris McCord
example of
my
misleading. Yeah.
Nobody ever trolls you on Twitter, do they, Chris?
Not directly. I usually get myself into the whole do not engage, and then I can't resist. Sometimes I have to, for the public record, I've got to correct the public record if I know other people may be influenced by something that is that I agree with. That would if someone that's not into Elixir, or they're Elixir curious, reads something and no one came to correct them, then they may not adopt Elixir Phoenix. So sometimes I feel the need to get involved where I probably should stay away.
Here's my analogy on getting involved in Twitter stuff, is that like you resist. It's like a big bag of like chocolate chip cookies, right? Like you look at this big bag of chocolate chip cookies. We're all in our 40s now, we're pushing 40s, and you know you shouldn't touch the cookies. Right? But eventually just like I'll just have one little nibble. And then you're like, all right, I'm in for a nibble, might as well go for a whole cookie. And before you know it, you're through the whole bag and you're looking at yourself in the mirror, you're like, I fucking hate you. And you're just like, I hate myself. I am a disgusting person. And that's the way, that's my analogy for how it is like getting into Twitter arguments and fights. Because it's like
Pretty much.
Yeah, I know. It's like you gotta treat it as something you have to just, I think if you stay out of it, you look better than ever getting into it, even with like the defensive. I mean, I'm as guilty as anyone when it comes to jumping into that shit, but I recognize that it has not ever done me any good ever.
That's true.
Ever.
Well, yeah, not me personally. I know that it's going to be a loss for me no matter what, but it's like maybe other random internet users out there will read this and be like, oh, I will try live view. So we'll see.
You're sacrificing yourself for the greater good.
Exactly. That's basically a live view story.
Somebody writes a post where they're like, I set up my Phoenix app where every request goes through a single gen server and it sucked. You're like, therefore Phoenix sucks. Like, I have to correct this.
Yeah.
I mean, I try to be fair too. Like I don't try to come in too fired up to things, but it just depends on the time of the day. If I'm in frustrated all day with other things, and it's like, all right, here we go.
It's the same with parenting, right? Like, try not to bring frustration back to the kids.
Oh yeah. I mean, I have recently, I'm losing shouting matches to a 2.5-year-old, and it puts you in your place pretty quickly, but also teaches you, all right, maybe that's not the right way.
Yeah, for sure. All right, guys. I think we should probably wrap it, but this was a good discussion. And I'm glad we kept the JavaScript rants to a minimum today. I look forward
next
to
time.
Yeah, I know there's another one queued up. So
we got a doozy.
Definitely.
Next time, more JavaScript rants on Elixir Roundtable,
aka Anti-JavaScript Podcast.
You're gonna get more people mad at Chris.
I think if we rebranded as the Anti-JavaScript Podcast, we'd probably get more people watching and listening. That's definitely a little broader in scope, right?
That's
Sure.
the marketing.
People tend to rally around it. Yeah, I think what the missing nuance there is a lot of that venting is like therapy, especially like Brian and I.
You got to get it off your chest.
We've been in the weeds of pain and misery, so everyone else doesn't have to. So I think a lot of it, like we may be coming on unfairly. It may seem like, oh, they're a little too harsh, but this is all from like lived experience. So just keep that in mind. But
it's also like, I'm just sometimes so blown away that things are that bad. It's like kind of like seeing a car accident. Like, did you see this? Like, I got to tell you about this. This is actually real. This is actually happening. And but in addition to therapy, I think it's also good to kind of justify why certain decisions are being made on certain things. And so it's not just like, screw it. There's history behind certain things.
That's true. So stay tuned for next time.
We're speaking in code right now. In every way, if you can read between the lines, like they should go out and try to figure out, just come up with the creative theories, put it on my Elixir status hashtag, and then we'll read the theories on the next Elixir Roundtable.
All right. Well, thanks, guys. Have a good afternoon.
Thanks. Good one.